Hi everyone, my name is Tantaya. I had recorded my video previously, but I just do this to show my face as it is part of the requirement set by Dr. Raja. And hope you enjoy this video. A very good morning I bid to my supervisor, Dr. KJ, and my coordinator of this course, Dr. Raja. Today I am going to present the methanol water distillation column, which was selected as my major equipment design. In my presentation today, I will be covering an introduction, design methodology of the distillation column, specification sheet that stating all the important parameters, the technical drawing, and last but not least, the cost estimation of my distillation column. As we know, distillation refers to a process that is used to separate a mixture of two or more components. While for this case, distillation column C105 is used to separate methanol from water. There are a few types of distillation column that commonly being used in the industry, for instance, pack column and tray column. The advantages and disadvantages for each type of column are listed in the table. From there, it is clearly seen that tray column is the better choice that suits the process in this project. This is because it is more suitable to be used for high pressure and high liquid load distillation. Besides that, it is relatively cheap compared to pack column and has better handling of fouling as well as good contact of vapor and liquid. The figure shows the distillation column C105 where stream 61 contains a mixture of methanol and water, stream 63 contains a high purity of methanol, and stream 64 contains mostly water. It is operating at a range of temperature of 40 to 103 degrees Celsius and a range of pressure of 100 to 120 kilopascal. Moving on to the design methodology, the number of stages of a distillation column is one of the most important aspects to be determined. To achieve that, I will have to calculate the minimum number of stages and also the minimum reflux ratio. For the minimum number of stages, it is calculated using Antoine equation, Raph's law, and Fensky equation, and I got the minimum of 12 stages. On the other hand, for minimum reflux ratio, it is determined by using Underwood equation, and I got 2.4163, with the assumption stating that the actual reflux ratio is 1.5 times of minimum reflux ratio, and through the use of Urban-Maddox correlation, the distillation column is determined to be 18 stages. By considering the tray efficiency using O'Connell correlation, the actual number of trays is determined to be 40 trays. Besides that, Kirkbride correlation is used to determine the feed inlet tray location, where the feed is entering at 24th tray from the top or 15th tray from the bottom of the distillation column. On top of that, according to the textbook that I referred, the plate spacing and plate thickness are assumed to be 0.45 meter and 0.005 meter respectively. From there, the tower height is calculated to be 20.8346 meter. Besides that, the inner diameter of the column is estimated, since the column is assumed to be in cylindrical shape, and therefore the diameter is calculated to be 1.29983 meter. Moreover, the shell thickness is included in the methodology in order to determine the outer diameter of the column. With the shell thickness of 0.001595 meter, the outer diameter of 1.3 meter is obtained. In addition, to determine the overall height of column, the head and closure of the column should be included in the design. With the height of the head and closure of 0.36588 meter, the overall column height is determined to be 21.566 meter. Last but not least, feed, distillate, and bottom nozzles are designed in terms of diameter and thickness. The values are tabulated in the table as shown. Moving on to the specification sheet, basically it summarizes the whole design of the distillation column. The parameters or the variables that I mentioned just now are included in the sheet. Of course, mechanical design of the column is included as well, such as bolts, skirts, nozzles, and so on. Next, this is the technical drawing that I came out with by using AutoCAD. The distillation column is following the exact dimension that I designed, whereas the holes and the trays are viewed in a larger scale. If not, they will be too small for an eye view. Last but not least, I have estimated the total cost of the column that I designed. It is the summation of the cost of the shell and the cost of the sieve trays, which is calculated to be 825,000 ringgit. That's all from me. Thank you for your kind attention.